Have you ever gazed at the moon, hanging like a silver coin in the inky blackness? And lost in contemplation, wondered if it could perhaps harbor its own moon, a celestial companion, a moon gracefully orbiting our moon? This isn't just a whimsical late-night thought experiment, it's a real scientific question, one that astronomers and astrophysicists have pondered. It's a question that challenges our fundamental understanding of how celestial systems are formed and how they evolve over vast stretches of cosmic time. The moon's long-standing partnership with Earth, a relationship forged in the crucible of space, has profoundly shaped our tides, dictating the rhythm of the oceans, and even influencing the length of our days, marking the passage of time. But what if a third player, a smaller celestial body, joined this intricate cosmic dance, adding another layer of complexity to the system? A submoon, a moon orbiting a moon, would create a miniature solar system right above us, a tiny self-contained world within our own cosmic neighborhood. This would dramatically alter our night sky, adding a new point of light, a new source of wonder, and a new layer of complexity to the celestial tapestry above. Exploring this seemingly simple idea forces us to fundamentally rethink gravity's role, its influence, and the delicate balance required for the long-term stability of orbits, the pathways that celestial bodies follow through space. Why do some planets like Jupiter and Saturn boast dozens upon dozens of moons, a veritable retinue of celestial companions, while Earth in contrast has just one solitary moon, a lonely sentinel in the night sky? By daring to imagine the possibility of a moon orbiting a moon, we push the boundaries of our understanding, testing the very limits of what's physically possible within the vast expanse of our universe. So, let's dive headfirst into the fascinating science behind this cosmic curiosity, exploring the myriad possibilities that such a system could present, and reveling in the sheer wonder of what it would mean, what implications it would hold, if our own moon were to have a moon of its very own. It's not just about adding another inert rock to the sky, another silent sentinel circling above. It's about potentially unlocking new and profound mysteries of the cosmos, peeling back the layers of the universe to reveal its hidden secrets. To see if a moon could have its own moon, a celestial body sometimes playfully referred to as a moon, we need to delve into the intricate world of gravitational forces. It's a cosmic ballet where size, distance, and velocity all play crucial roles. We need to understand gravity's delicate balance. It's not just about how strong gravity is, but also how it interacts between multiple objects in space. Earth's gravity holds the moon, keeping it in a stable orbit around our planet. This gravitational embrace is what dictates the moon's path and prevents it from drifting off into the vastness of space. Just as the sun's gravity holds Earth, dictating our planet's yearly journey around our star, the sun's immense gravitational pull is the anchor of our entire solar system. Now imagine the moon trying to hold on to a tiny sub-moon, a small asteroid perhaps, or a captured space rock. Its gravity is much weaker, making the task of holding on to another object significantly more challenging. Only about 1/6 of Earth's. This difference in gravitational strength is a critical factor in determining whether a sub-moon can maintain a stable orbit. For a submoon to stay in orbit, it needs to find a delicate balance within the moon's gravitational influence. It must be close enough to the moon to resist Earth's powerful pull, which constantly tugs at any object in the moon's vicinity, but not so close that tidal forces tear it apart. These forces, generated by the gravitational gradient, can be destructive if an object gets too close. This creates a tricky three-body problem, a complex gravitational interaction that's notoriously difficult to predict with perfect accuracy. The moon, the submoon, and Earth, each exerting its own gravitational influence on the others, all tugging at each other, creating a dynamic and ever-changing gravitational landscape. The submoon would need to orbit in a Goldilocks zone, a region where the gravitational forces are just right for a stable orbit. Not too close, not too far, but perfectly positioned to maintain its orbital dance around the moon. If it strays, even slightly from this ideal zone, its fate could be sealed. Earth's gravity could snatch it away, pulling it into a new orbit around our planet, or fling it into space, sending it on an endless journey through the cosmos. Imagine trying to whisper to a friend at a loud concert. The surrounding noise makes it difficult to be heard. You have to stay close, speaking directly into their ear to ensure your message gets through, or the noise drowns you out, and your words are lost in the cacophony. Similarly, a submoon must cling tightly to the moon, staying within its gravitational embrace to avoid being lost to Earth's pull, always threatened by Earth's overwhelming gravity, a constant and powerful force in the lunar neighborhood. This fragile balance is why the existence of a moon is so challenging, a testament to the complexities of celestial mechanics. The cosmic dance of gravity is precise, a delicate choreography where every movement is dictated by the laws of physics. And even a small misstep can send a submoon tumbling away, lost to the gravitational forces of the larger bodies. That's the heart of the puzzle. The question of stability in a dynamic gravitational environment. Can a moon survive this gravitational tug-of-war? Can it find a stable orbit amidst the competing forces? Let's look at other worlds for clues, exploring the diverse planetary systems in our universe to see if we can find any evidence of these elusive moons. Moons are ubiquitous celestial bodies scattered throughout our solar system and beyond. They dance around planets, each a unique world in its own right. But our Earth-Moon duo stands out, a cosmic pairing unlike any other we've observed. It's a relationship that has shaped our planet in profound ways. Our moon is unusually large when compared to Earth, a significant fraction of our planet's size. This size disparity has major implications for the dynamics of our system. This gives it a strong gravitational influence, a pull that dictates the rhythm of our tides and subtly affects Earth's rotation. This unique relationship stabilizes Earth's axial tilt, preventing extreme wobbles and ensuring relatively stable and predictable seasons. This stability has been crucial for the development of life as we know it. This is unlike the swarms of small moons that huddle around gas giants like Jupiter and Saturn, each with their own orbital dance. Jupiter and Saturn boast dozens of moons, a diverse collection of celestial bodies orbiting these giant planets. Some are massive, spherical worlds, while others are tiny, irregular fragments, likely captured asteroids. Some Saturnian moons even have Trojan companions, following them along their orbital path. These are small moons sharing the same orbit, locked in a gravitational dance, but they aren't true moons, orbiting another moon. These complex systems demonstrate that multi-body orbits are indeed possible, showcasing the intricate dance of gravity. Yet, despite the prevalence of moons, a true submoon, a moon orbiting another moon, remains elusive, a theoretical curiosity. What accounts for this difference? What makes a submoon so difficult to form or maintain? The gas giants' moons are significantly farther from their planets compared to our moon's proximity to Earth. This greater distance creates more stable regions, wider zones where a submoon could potentially find a safe haven. Our moon, however, is relatively close to Earth, locked in a tight orbital embrace. This makes its gravitational neighborhood crowded and unstable, a challenging environment for a submoon to survive. The proximity to Earth's powerful gravity is the main obstacle, the dominant force shaping the moon's orbital environment. While the gas giants' moons might therefore have a better shot at hosting submoons, offering a more hospitable environment, our moon faces a much tougher challenge, navigating the complex gravitational forces in its vicinity. The search for a moon is, in essence, a search for stability in a chaotic environment, a quest to find a pocket of gravitational harmony. So, given these challenges, could our moon ever realistically keep a companion of its own, a smaller moon orbiting our familiar lunar neighbor? Let's delve deeper and find out. So, is it possible for our moon to have its own moon? Science says it's highly unlikely. The moon's Hill sphere, the region where its gravity dominates, is small due to Earth's nearby mass. A submoon would need to orbit deep within this sphere, but tidal forces from both Earth and the moon would destabilize it. Over time, these forces would either crash the submoon into the moon or fling it away. Computer simulations show that stable orbits for a submoon are extremely rare and short-lived. Only very specific retrograde orbits might last, but even those are fragile. Still, it's possible that in the chaotic early solar system, the moon briefly captured a small companion. Perhaps one of the moon's craters marks the end of a long-lost moon's journey. In our current cosmic arrangement, though, a permanent moon just can't survive. Imagine if a moon did exist, how would it change our sky? We'd see a tiny speck orbiting the moon, a new object for stargazers to track. It could create unique eclipses, a submoon passing in front of the moon, or casting a tiny shadow on its surface. Its gravitational effect on Earth would be negligible. No extra tides, just a new wonder to observe. The real impact would be on the moon, with tiny rock tides and a slow outward spiral, mirroring the moon's own drift from Earth. For scientists, It would be a living laboratory for studying orbital mechanics. For the rest of us, it would add a new layer of beauty and mystery to our nights. If a moon is unlikely here, could they exist elsewhere? Astronomers have searched for submoons around Saturn's Rhea and Jupiter's big moons, but so far, none have been found. The challenge is immense. Submoons are tiny, faint, and hard to spot next to their bright parent moons. Future telescopes may finally reveal these elusive worlds. The discovery of exoplanets was once a dream. Now we know thousands. Perhaps one day, we'll find the first exomoon and then a submoon. Such a discovery would reshape our understanding of how complex planetary systems can be. Why do we ask if the moon could have a moon? Because imagination drives science. Every breakthrough starts with a bold question that challenges what we know. Exploring moons tests our understanding of gravity and orbits, pushing our theories to their limits. Even if we never find one, the search inspires curiosity and wonder. It reminds us that the universe is full of surprises, waiting to be discovered. By imagining new possibilities, we deepen our connection to the cosmos. We are a species that looks up and asks, what if? And in that question lies the heart of exploration and discovery.